Welcome to Stay Sharp in Digital Engineering, your key to unlocking success in the digital evolution of products in manufacturing. In this episode, we talk with AI expert Alex Bruskin about the evolving role of artificial intelligence in digital engineering. We explore how AI is shaping the future of engineering, from data migration to quality assurance, while unpacking why human oversight and strong data foundations remain essential. Get your note taker ready and let's jump in. Welcome back, everybody, to Stay Sharp in Digital Engineering, the podcast about all things digital related to products and engineering, manufacturing, service, and more. I'm one of your hosts, Julianne Grant, and I'm joined today by my co-host, Jonathan Scott.
Hello, everybody.
Hey, Jonathan, we're back.
We're back again, and for another fun one. This is going to be an exciting one today.
I totally agree. So today, our topic is about AI, and we all know it comes up a lot on this show. And there's certainly a lot of hype around the topic. But we wanted to challenge some of that hype today and get into what's real and not so real about the promises being made regarding AI in digital engineering and the manufacturing space. So to do that, we have invited a special guest with us today, Alex Bruskin. Welcome to the podcast, Alex.
Nice to meet you.
Great to have you. Yes, again. It's always good to see you. So let me tell you a little bit about Alex. He's an interesting person. Alex brings 25 years experience in PLM and digital engineering, and his work with clients in aerospace, defense, and other complex discrete manufacturing industries. His work has consistently focused on optimizing the crucial connection between IT and engineering, including integration, performance, and data transformation and validation. He's very passionate about addressing the significant void in the digital thread, specifically concerning technical publications that use AI tool sets. And that's why we have him here today in the hot seat. So if you want to stay on top of AI tool sets in this space, I really recommend to go find his LinkedIn profile and follow him. He shares some very interesting insights and publishes a regular newsletter from his research. So with that, I'm going to hand it over to Jonathan.
Yeah, I want to jump in, right? Because this is a really fun topic. We've talked about it a couple of times on the podcast, but to have somebody as expert as you, Alex, is great. So AI means a lot of different things to people right now because of how much hype it's getting, and it's like people hear it and they think all kinds of things. So I won't try and nail it down here and define it here, but I do want to frame the conversation a bit so that our audience understands, where we're coming from, how we're coming at the conversation today. So I really want to get your view on the AI space and which pieces have maybe near-term and long-term applicability to the world of CAD, PLM, MES, MBSE, this whole digital engineering space. So let me just say that's kind of what we want to talk about in terms of focus, but yet not focus. So let me start with a question. How would you summarize the technology in the AI space, at least the parts that might be relevant to digital engineering?
Well, it's a big question, and
yeah.
There can be really a lot of explanation of, we can turn ourselves into a big knowledge graph while we're explaining that. So I would probably start with a very generic and historical statement that the AI, artificial intelligence, is not really new. The topic exists for maybe 60 years, and it started back during 1960s, mostly for military purposes, when people try to optimize very complex processes. And then it went on, come and go, natural language processing, computer vision, different machine learning tools, neural networks this, neural networks that, until really maybe only 10 years ago, less than 10 years ago, there was a breakthrough in the generative AI space. Again, based on certain theorems, based on certain papers that were released back in the 1980s. And then suddenly there was this magic bundle of availability of computing resource because it was simply impossible to do it before. GPUs and NVIDIA made it happen, made it possible. So we have compute, we have mathematical foundation, and we have availability of data. Everyone hates or loves to hate OpenAI, but what they did, essentially, they went through the internet and combined everything. And then, based on that mathematical foundation and this immense compute, they created something that caused people to be overexcited, beyond reason.
We're very excited.
That is the kind of foundation of how we came here. It's more or less like iPhone moment. All the technologies existed before, but they existed not enough and not in the same place at the same time. But then Steve Jobs figured out how to get it together, and then, miracle happened. So AI is more or less the same moment from my perspective.
That's interesting. I didn't realize it was that convergence of a couple of things that made it happen, right? I thought it was the discoveries of things, algorithms, that sort of thing, but I didn't realize it was that convergence of, capacity in terms of compute and things that we maybe already knew, and putting that together with data, and suddenly we're all interested. Interesting.
Yeah. And then the next thing is why AI became so important, and this is a combination, again, of an extreme need and suddenly available capability. There is this paradigm of why, what, how, and I like to add it when, who, and where. So essentially, why? Because there is a huge sensory overload, there is a huge information overload, there is a huge increase in complexity, and Julian, you mentioned a lot about me, but I'm also a movie buff. And one of the movies that I highly recommend everyone to watch is The Final Destination. Not because it's a good movie, but because it's an engineering movie. It's a movie about Murphy Law par excellence. Okay. Essentially, everything that can go wrong goes wrong at the same time. So this is essentially the situation right now with a lot of things. You look at Final Destination, it's a movie. But then you look at Boeing debacle, right, and it's not a movie. And then you look at a lot of other things, and it's essentially crisis of complexity. Humans have reached certain limit of how much they can perceive, how much they can process, and how much they can share with other humans efficiently. So this is and here is a joke that I invented some time ago. Like, everyone is speaking about artificial intelligence, and instead want not to call humans protein-based intelligence. So I like there is a limit. So there is a limit of protein-based intelligence right now, which, if unmitigated, would lead us to a certain standstill in terms of development, in terms of efficiency, in terms of just pure safety. There are too many moving pieces. And here I would like to, mention someone I very much like in terms of explaining of so-called systems thinking, C.J. Eunice. You may look him up on LinkedIn, and he's speaking on every once in a while on different podcasts. He's a great thinker in terms of explaining how things are complex, how to structure them, not to simplify them necessarily, but how to make them available for further consumption, if this is possible at all.
Right.
And then there is this very unhappy topic of the humans themselves.
The unhappy
beyond
topic.
Intelligence. Yes. Because on one side we have, humans created a lot of stuff, but then they reached their limit in terms of just compute, let's call it compute,
right?
Hardware and software. But then there is a pretty recognized topic of human ethics, working ethics, and also great retirement. Like, it's an open secret. So people want to work less, and they are less focused on work. So suddenly we have a kind of crisis. The complexity is increasing, the amount of information is increasing, but capability and willingness of humans to deal with that situation is decreasing. So the AI is a kind of mitigating factor, and it's nowhere as important as in engineering, because engineering is expensive, and then the cost of mistake might be too high to bear alone. So AI is suddenly a great mitigator for so many problems.
That makes sense. And I think, to your point, that's where, when we think about how it fits in this digital engineering space, that's what's so interesting to me. I mean, I see all the hype, and I'm using AI. It feels like everybody's using AI these days, to assist me with certain tasks. But where it feels interesting to me is when we aren't talking about, the application of the large language models to an engineering data set, right? And I see where that fits, natural language processing, that kind of thing. But when we start looking at sort of novel applications of it, like, well, where do these concepts help us out in other areas in engineering? Is there any of that you see that people should hear about or should understand so that it's not just, oh, yeah, ChatGPT on my PLM?
Yeah. So again, going back, artificial intelligence is a substitute, in a sense, to protein-based intelligence. So what people do, what engineers do, they design things, they move mouse, they press keyboard, they change the design. Then they also work with MBSE tools, with these days with SysML, they create requirements. They export it into 3D models and so on and so forth. So, all that host of activities. And then we recognize it's all about language. An engineer knows how to do things because he or she was explained how to do things. So if we can convert that knowledge, that method into verbiage, into generated verbiage, next token prediction as the term, then we can potentially optimize that process.
So let me stop you there, because I think what you're saying is a really important point. I think, right? But I want to ask it as a question. The AI that we think of today, like you said, it's prediction, large language models, it's prediction. It's look at the statistics of the data set, what's going to come next. And we interpret that as intelligence, right? So I think your point you're making is when you think about engineering, it's its own communication language, right? So yes, we use English and it's a proxy for these things, but we're trying to communicate concepts and scientific principles and those sorts of things. But there's this body of knowledge that is its own language. But the idea is, wait, could AI, instead of predicting the next word in English or Spanish or a language, could it predict the next thing in that engineering language? And could that, is that what's valuable to us? Is that what you're talking about, Alex?
Both yes and no.
Okay.
So if we are speaking about something where next token prediction, like just saying big or large, they're synonym, it's not that critical. So if this is your problem, then generative AI can do that. But if it requires precision, it requires additional methods to do that. So if we are speaking about MBSE, if we are speaking about SysML, this is one of the examples where I see like a direct application of generative AI. If we are speaking about Copilot for design, then generative AI is not enough. You also need to add a lot of training. You need to train on the right data. And here I may essentially bring that sensitive topic of recent Grok going insane. And people think that Grok was a Nazi, but it was not. It was simply trained on a body of data that was available to it. Like if on the internet, 90% of the people posting, let's say, substandard content, Grok is starting to learn from that content.
Right.
And it starts thinking more or less the same way. And in a similar manner, just a couple of years ago, when the trend was very different, there were so-called trust and safety councils who steered the content in an absolutely different direction. Not content, the weights. So it was possible to make one type of jokes, but not possible to make another type of jokes. And this is exactly what's happening in engineering too. Like if you can steer the design on the right data, if you can validate that it is doing right decisions, then you can use it. And here is a great example of how to do that. There is this new company, GetLeo, that are now friends with PTC, with OnShape, and they are essentially doing that very stuff compared to many other companies that are creating wrappers on top of generative AI. They actually spent compute, I guess, and huge amount of money on training, and then they managed to produce certain results that are very close to reality because, again, they spent a lot of time and money on that. And at the same time, I'm sure that speaking about like bigger picture, if we're all in that business, companies like Dassault, they were there before. Look at their knowledge ware in CATIA. They essentially did very similar things before. You want to solve that kind of problem, then use that type of material or use that type of configuration. And C are doing the same. So now suddenly we have another player, but eventually, if we're speaking about Copilot, yes, it's already there, but it's expensive and only a few companies would be able to do that.
So how could a company train an AI algorithm or the large language models? Like, what would be that process? You mentioned an application, but is that the only way to do it?
Well, if we're speaking about training, there is a combination of methods there. If you look at a certain design, and then you say, this design is good. What are the qualities of good design? Then you structure it. So there is a certain so-called reward mechanism inside LLM, inside generative AI, which rewards the model for giving a better answer. Kind of rewards it.
Okay.
So you're training on good data, and the more good answers it produces, the more precise answers to what you see as a trainer. Like you're training a dog, right? You can say when a dog is doing good or dog is doing bad. You can assess that, you can validate that. So think about AI doing more or less the same thing, what you do with generative AI. And then there is naturally a combination of method with a dog and with AI. A dog can listen to the sounds, a dog can see with eyes, a dog can react on certain things, on sweets or treats. So if you can manage the algorithm more or less the same way on the algorithmic level, so why not? But this is a pretty complicated task, and this is very expensive type of projects, which is possible only for a very dedicated and well-funded organization.
Well, and I think I'm going to put a couple of topics you mentioned together there, Alex. When you were speaking earlier about one of the needs for AI, the reason we need it is this complexity, this exploding complexity that we have to try and manage. And then when you connect it to that point about training, to me, that's where there's a real challenge because, training a dog, we sort of simplify the problem into prompt response, kind of thing. And right. You even mentioned it, there are a couple of different mechanisms why we prompt. We don't even realize they see what we do. They hear what we say, so it's complicated in its own right. But then when you think about, the real world and engineering is meant to take into account all of the different things in the environment, the physical rules, all these things, it's like training for that, it requires a certain level of, like you said, precision. It's not like language where you say big or large, okay, fine, I understand what you mean. With engineering, there's precision required, which I think part of what you're getting at is, so then training becomes more challenging, more difficult, because that complexity, the amount of complexity you have to manage in the training, just it costs more in terms of compute or whatever it might be. Am I catching you right in terms of how those connect?
Yes, more or less. It's, you need to train a dog, but then you need to train a human child. Right. That's true. And sometimes you need to train a teenager, which is, a different topic. So the amount of complexity increases, but then the brain power increases too. So you suddenly get more options, and you simply need to utilize those options. And then you get, and that's, I guess, one of the next questions, like, does generative AI work alone? No. There is such a thing as multimodal LLMs, and there is a combination of computer vision with neural networks. So, it can look at things, and can appraise things, comprehend things, and then you combine it with graphs. So you structure the relationship between different entities, between different concepts, and kind of help to generative AI to better balance it, to figure out where is the treat.
Right. Yeah, to use multiple modes, to your point, like, yes. Showing the dog the prompt and calling the dog, it's like, correct. You give it the different inputs. That makes sense.
Yeah. Right. What would help me is if we kind of shift to talking about some use cases, because I think, I'm getting some of the theory and some of the things you're explaining. But in our digital engineering world, what are some use cases that you're seeing that you find interesting?
And here I can tell you about this project that we undertook on ourselves a year ago when we heard all this hype about AI, and we were overwhelmed with that hype too. We were overexcited, and then we decided to structure ourselves and simply start writing down whatever we hear from different people. Doesn't matter. We don't judge anyone. We don't, condemn anyone for strange or stupid opinions. So we started writing down whatever people thought would be a good use case for AI. So we wrote altogether about 70 use cases, perceived use cases. Out of these 70 use cases, about 6 or 7 only made any sense at all.
Fair enough, right? You could expect that.
Yes.
80-20 rule.
And then out of these 6 or 7, there were 3 that we said, we as a company, as Centicor, we can probably handle it. The case that we couldn't handle was exactly the case that GetLeo, for example, are handling. They are creating Copilot for digital engineering, for CAD design. Why? Because, they can afford it. They are very well funded in that sense. So we said we have less access to funding, so we need to be kind of smarter. We need to laser focus on a very narrow use case and or at least a couple of use cases. So we identified 2-3 use cases where we saw that we can get return on investment very quickly and bring value to the customers. So one case is, we call it data enrichment for research purposes, where imagine you have a standard parts database with very dirty data, with bad descriptions, where people look at, they're searching for a nut. They want to find a stainless steel nut, but then instead of stainless steel nut, they get a nylon nut by mistake, and it snaps in the field accidentally. Why? Because people were updating, loading that information for decades, and there is no way humans can handle that. So what we found, that AI can kind of augment that data. It can enrich that data. And then speaking about a combination of technologies, LLM itself can only enrich, but then we attach it to semantic search with Elasticsearch. And then suddenly we can search big and find large. We can look for stainless steel and find S period, because semantically it's very close. And we can provide information to the user and let them decide what is the really good answer. So that's one of the cases. Another case, and this might be kind of interesting for you at Razorleaf, because you are involved in the upgrade and migration projects every once in a while. Every upgrade and migration is a disaster. Why? Why? Because there is a source data.
We call it a challenge, Alex.
Yes. It's a disaster area. Yes.
Yes.
So everyone, is unhappy on the old side, and then there is also a new side. And, you have old data model, which is very often intentionally obfuscated by the vendor. It happens. And then there is a new model, and you need somehow to extract that data in a good sense, not lose anything. And you know very well probably how people are trying to figure out, like sitting weeks after weeks, trying to create SQL statements or trying to create the right API combination to extract everything and to lose nothing, or to lose, let's put it honestly, to lose as less as possible.
Yep.
And it's a huge cognitive load on developers, on everyone involved. And the price of mistake is pretty high. So generative AI is precisely a good fit for that purpose, because it looks at the data model as a language target.
Right.
It can say, okay, it looks like this table is connected to this table. It looks like we have a foreign key here or primary key here. It looks like there is that ID in that table, and it corresponds to that ID to another table. And then it can translate that thing into SQL. So suddenly you become able to construct this data extraction mechanism maybe 50, 70% faster than you would do it otherwise, than you would do it with pure humans who need to be super focused, super experienced people in that, in the domain of the original source data system, and then there should be super expert in the target system. So that's we saw that thing happening.
Yeah, that's a really interesting case. Yeah, I mean, because to your point, that's one of the things that we do with migrations, right? Is we have to bring the expertise from the different pieces, the experience at one, the experience at the other, the architecture of the two together, and it's a quite involved project, particularly the more details you get to, and also needs some precision. So, to your point, it's a big challenge, and what you just described is an interesting way to try and shortcut some of that. In your first case, though, Alex, you mentioned something, and I want to make sure we don't leave here today without me asking this question about that, because I think it's a very important one that I know lots of people are talking about, at least in this digital engineering, digital thread type of environment, and that's about data quality. So the thing I'll sort of give you the question that comes to me that I have a very strong opinion about, and see what you have to say about it. Can we go do all of these amazing things with AI if our data quality isn't good? Right. So does the data quality matter to the use of AI? And if so, what ways? Because I imagine there might be more to this than just a yes or no answer.
Let me ask you again, like as a protein-based intelligence, like what you as a protein-based intelligence would do if you deal with bad data. First of all, you would probably, you're long enough in that field, so you would recognize that you are dealing with bad data.
Right.
The question is how to recognize you are dealing with bad data. And here, generative AI can look at it from different perspectives. One of them is there is a method, and early in the game there were people laughing at OpenAI because it said 2 + 2 = 5.
Right.
Why? And other things like that. Why? Because for generative AI, for next token prediction, it doesn't matter. It just follows whatever randomly, not randomly, but statistically close to it. 5 is pretty close to 4.
Right.
So what people did after that, they created so-called solvers. They created specialized tools that are responsible for particular things. Like if you need to appraise a certain problem, right? If you need to fix your piping, you don't do piping yourself, you call an expert.
Right.
I mean, you can do it yourself, but then you get 2 + 2 = 5. Accidentally. But then you call a real guy, and he knows how to solve a problem. So here is the same. What people are doing now, what those vendors are doing now, they essentially teach generative AI to call the right function. So when you ask it 2 + 2 = what, it doesn't try to answer it yourself in a generative AI manner. It calls the arithmetic engine, which says F 2 and 2. First attribute.
Right.
2, second attribute 2, and then essentially you add one to another and you suddenly get 4.
But the point is, it's not AI doing that, right? It's
AI
knew how to feed the solver, and it knows how to give you the result from the solver.
Exactly.
But it's like its own agent, so to speak. I mean, I know we're not really talking about agentic AI, but yeah.
So this way you can achieve quite a lot of precision. And the same here, you are dealing with computer vision. If you look at a picture, one example is how to deal with legacy data, legacy drawings, for example. You want to get information from legacy drawings, including, like, you want to get efficiencies, you want to get part numbers, you want to get notes there. Can you really rely on generative AI to do it? Probably no, but there is a system that can do it. It's called neural networks. It's computer vision. Convolutional neural networks solve that for many, many years. So what you do, not you, but what vendors do, they have a subset of functionality dedicated to that CNN, to computer vision. They see that image, upload it to CNN. I'm oversimplifying here.
Yeah.
And then they get something back, and then generative AI can operate with that data pretty flexibly, the same way as it operates with anything else.
Yeah, it's funny because so many of us will probably see those kinds of solutions, just like the 2 + 2 = 5 example you gave. We'll see it as AI, because it's like an AI wrapper around it. But really what AI is doing is figuring out the right solver to call, the right way to coordinate the activities and still give us the answer we want.
And it's not always like that. If you look at people, the models are getting better and better in mathematics, in reasoning. How they do it, one of the things they do is they train it on the right data. They teach them the way, they say, look at how great mathematical people do that.
Mm-hmm.
Because mathematics is a language. Physics is a language.
Right.
If you can, essentially, you can get from one formula to another. Formula is a sentence.
Yep. No, that makes perfect sense, right? So it fits back in that AI model again.
Exactly. So that way, certain things you can resolve with AI reasoning, which was trained on the right data, on the right method. Others you can resolve using the solvers, specialized solvers.
So does that tell us, come back to my question about data quality in AI, I think what that tells us is, no, the data quality matters a lot, right? Because if you're trying to train your AI or you're asking it to work against data that has errors or mistakes or even, let me go so far as to say, data that's not connected. If you ask the AI to make the inferences, it could make the wrong ones. And then if you make decisions based on those bad inferences, that's not good.
That's not good. That's why we personally think that there should be, for the time being, a human in the loop, always. Right. That's why in that solution that I told you about with search for standard parts, we did not say, okay, this is the right answer. We created what we call proximity score. So we say, okay, this value looks like 90% what you need, and this looks like 89%, and so on and so forth. So a human eventually decides what part is closest to what he or she is searching.
It's interesting. I would find it a little scary to think when you wouldn't want humans involved, because context means everything in looking at some of this data. And to think that we are going to get to a point where a machine can do all of that is concerning. But for me, yeah, I'm back to the Terminator. Well,
if you look at the Terminator, look what is happening, in a real warfare where right now in Ukraine, people are sending drones in both directions, and some of those drones are kind of artificial intelligence capable, which means that they can make certain decisions, or they know where to fly, they know how to identify a tank or a truck using a computer vision database. They know how to do that because they were trained on that, but that's not generative AI, that's computer vision. But then they can convert a certain command that humans are given to it into a plan of action. Let's call it work plan. So but still, humans are somewhere in the loop, but eventually you send the drone in the right direction, or you create an assembly in the right direction and hope it will be for the best. But then you would better either to look at it yourself or involve special validation tools that are precise in order to figure out if something goes
right. Yeah.
astray.
Yeah. Keep that check in there. Yeah.
Yes.
Okay. Yes.
And gentlemen, I'm going to have to put a whistle to this timeout.
No, it's good. It's good.
Yeah, this has been an excellent conversation, Alex. Very interesting. Learning a lot here. So, but I think it's time for our to wrap this up, and we want to be careful of our time and our listeners' time. So I'm going to move it over to Jonathan. I'm sure you have some interesting notes for us.
Absolutely. I've been taking notes, as you probably see me looking away as we're talking.
I do.
A lot of things that we talked about today, and Alex, where I missed something or didn't get something right, please jump in and correct me. But I think first thing we really touched on was about the history of this, where we came from. And I think that's good context for us to have about AI and digital engineering. And the idea is it wasn't just all of a sudden this popped up. It was a convergence of compute power of some algorithms that maybe we already knew, and about data to train those algorithms on with that compute power. And you needed all three of those. That's what got us to the things that are getting us so hyped up today. But nonetheless, it was sort of a breakthrough that we got those three things together and now see this interesting value. But it's what it's doing for us, and the thing that we should all think about, like, is it really intelligence or is it prediction, right? And that's how it connects back to our digital engineering topic, AI in digital engineering. Right now, it's predicting language, English language. That's what we all see in these large language models. All those statistics from all that data we studied and computed on means that the next logical thing is X, whatever that is. Well, okay, hopefully soon we'll be using that on the language of engineering, right? Like you mentioned, MBSE is a possibility there. These languages that we could put it against the data set and get some answers out. But all of that relates to the training topic. And there's this complexity problem, right? Where we've got to balance the complexity of the problem we're trying to solve and the language we use to represent it and the inputs and the outputs and how much training you have to do with how much compute to get good answers out. And the more precision you need, which is another really great point you brought up, it really will determine how much resource you have to put at it to get the answers that you want. So that's the thing for us to think about as we're trying to apply this. Now, some use cases we talked about, I thought these were really interesting. Cleaning up data is a good one, right? Because I asked about data quality at the end, but one of the first use cases you mentioned was, hey, you can use this to augment and enhance data sets, and AI can help us with that sort of thing, but not necessarily, fully autonomously. So can help, but it's not always exactly the answer. Data migration was another good one. Precision's required. It could help speed up the process. It could help reduce that cognitive load and let people focus on what's needed, but not necessarily solve the whole thing. So I think where we ended, at least in terms of what I understood, is this idea that AI isn't the right solution for everything, but it is a good wrapper. It is a good way to interact. It's a good way that it can determine the right solver to call at the right time to help deal with those really complex problems. So it's sometimes we may call it AI, but it may be a number of pieces of technology that we put together and AI helps orchestrate for us. But in all of that, the data quality will still matter, right? What good input is going to get you better output and bad input will get you bad output. And we have to watch it. And I think to that Terminator point at the end, that's the key. We can automate and we can do a lot. We can save a lot of cognitive load. We can address a lot of complexity. But for right now, we definitely need humans in the loop because the bad data it's there. It can creep in. It can be there. So out of everything we talked about, what did I miss? What did I not highlight that I should have mentioned?
I guess that's more or less everything, like drive safely, right?
Right. Compute safely.
Yes.
Yes. Yeah, absolutely. That's the ultimate thing. This is a great technology.
Now. Yes.
That's a great technology, and it offers a lot of possibilities. It simply requires certain way to be careful, the same way as you drive. You are required to drive safely with certain restrictions. So you are supposed to use AI with other restrictions along the way. And that's pretty logical.
That makes complete sense. Yes.
Yeah. Any parting thoughts for us, Alex, or we good to wrap up? Is there something we didn't touch on that you want to add?
Probably the last thing that we discussed before, one of the use cases of all these 70, as I said, we had 70 slides with perceived use cases, 7 use cases that we thought, made some sense, 3 use cases that we kind of focused on. I mentioned 2, and the third one is something that we're working on right now, and this is exactly what I'm passionate about. This is the thing, what we call the gap between engineering and manufacturing, between specifically engineering documentation, so-called tech pubs, when they are produced on the engineering side as mostly PDFs, and where, this is great for companies that produce technical manuals because it's very convenient for them, and it's legally convenient for them too, because then they can prove they supplied what was required. But then those PDFs come to the manufacturing side, and on the consumption side, this becomes a pretty strange problem when literally people have to deal with thousands of pages, or they either jump between those pages in PDF, or they have to print it. And this is really funny. Like in 2025, people are printing tens of thousands of pages and distributing them to stations. And this is a daily reality for many companies that are otherwise very modern. So what we call now, this is what we do. We call it PDF reconstruction. So using AI, this was not possible before. This became possible only recently,
right?
When the technology matured enough on LLM side in terms of combination, both the capacity of the models like LLM, for example. I don't want to go too deep.
Yeah.
But, I'm very tempted.
But this is clearly something you're passionate about, right?
Right.
I mean,
Yes.
and it makes sense. So I'm glad you brought that up as, something for people to hear about. Like, these are the applications, right? These are the things that people are working on,
yes.
right? And you guys in particular, this is the kind of thing you're trying to solve. So I think this has been a great conversation. So thank you for all that insight and the things that we see that AI can do. Julianne, I think from a summary perspective, I think we hit it all. So
You did. You hit that one out of the park. That was great. And Alex, this is excellent conversation. Thank you so much for being here today and being our guest.
Yeah,
And
thank you,
of course,
Alex.
Thanks, Jonathan, for being here with me. And, we would love to keep the door open because I know, Alex, you're doing a lot of research in this area. So maybe we can have you back and later in the year and get an update on some of your research and where you're going with AI. That would be great.
Thank you.
All right. So with that, everyone, we're going to close out today's episode. If you like this podcast, please be sure to give us a like. And if you have any questions for Alex or about this conversation, please be sure to put it up on our post or send us an email at podcast@razorleaf.com. And with that, we're going to wish everybody a great day. And thanks for tuning in. Until the next time, everybody, stay sharp.
Thanks, everybody.
Thank you.
Thanks for being here and listening to this episode of Stay Sharp with Razor Leaf. If you like this podcast, please be sure to hit that like button. We'd really appreciate it. And subscribe to our podcast on your favorite podcast platform or check us out on YouTube. If you have any questions, please leave us a comment on our post or send us an email at podcast@razorleaf.com. Until next time, everybody, stay sharp.